Hey, what's up, guys? This is Cheng here. So let's take a look at this week's weekly contest problem, number 1643, case smallest instructions. So this problem, it's a hard problem, but it's kind of tricky because this one is more like a math problem rather than a regular or either like a DP or like other problems. So basically, you're given I'll just skip the those kind of descriptions here. I'll just use these examples here. Basically, you're given like a destination, which is basically is the coordinate of a 2D here, right? A 2D plane here, and another K here. So so the process is you need to from 0, 0, and you're starting from the 0, 0, and then you end with this destination, in this case, which is the 2 and 3. And then, as you guys can see, there are many ways you can get to this location, right? And every time you can either go to right or you can go down. You only have those two options. And if you go to right, it is as if you are going adding a H instruction, which means the horizontal. And if you're going down, it means that you're adding like a V instruction, which is the vertically. And based on your choice, either you go to right or you go down, you will end up with a unique path, okay, with H and V. And as you guys can see here, so H is smaller than V, okay. And here is the tricky part. Basically, you need to find the case smallest, the case smallest instructions among all those instructions. As you guys can see here, we have 10 instructions in total because we need to make a 3H move and 2V moves. That's why we have 10 in total, and we need to find the first one. So the first one is HHHVV. That's why we have this one. And some other examples here, same thing here, same destinations, but this time we need to find the k equals number 2, which is the HHVHV, right? So, I mean, the intuition is like this. Basically, actually, it already gave us some hints here. So the hint is this one. I mean, the total combinations is the what? It's a n so NCR means the combination of this row plus column. Yeah. So here we have 3H and the 2Vs, right? And the total combinations of this 5 letter is what? It's 3 plus 2, right? Basically, we need to have like the combination. The combination of 3 plus 2 out of 2. Basically, we're selecting 2 values out of 5. So how are we going to calculate this, right? We have like what? 3 times. No, we have sorry. If it's a com 5 2. So it's gonna be what? It's gonna be a 5 uh, times 4, right? Times 3, and then divided by 2 times 1. Sorry, I think it's the 5 factorial, right? Divided by 3 factorial times 2 factorial, right? That's the combination, which is 10. That's how we get 10 here, right? So actually this problem is more like math plus the DP plus the greedy. I'll give you some examples here. Since we have a K here, right? So let's say we have a HHV, and then we have a X, 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 X here, right? And let's say we have already fixed HHV here. Now we're at this location here, okay? And assuming we have 2H and 4V's left in this range here. At this location, right? At this place, we basically we only have two options, right? With the current K here, with the current K's smallest number we need to match here, we can either put a H here or we can put V here. Okay, it depends on what. So depending on how many letters, I mean how many can we afford putting V here? So why is that? Because if we put H here, let's say we have a like case remaining here. If we put H here, it basically we're still using the smallest possible options here, right? So it means that we still need to make like a case bigger number than the current options here, right? But if we're putting a V here, okay, if we're putting a V here, it means that okay, we are skipping all those numbers, all those like the possible numbers who is starting with H from the current K. Basically, we're skipping that. So now it's easier to solve this problem because all we need to do is just that we just need to see if we can afford putting a V here, which means that by skipping all the numbers that's starting with H, if we can do that, then we'll put a V here. Otherwise, we'll put H. Okay. And then the next problem is that how can we find all the numbers that's starting with H? Right, so let's assume we have in total we have 6 here, right? How about all the numbers starting with H? It means that we are we're removing this H, and we have 5 here, right? So we have a 5, we have C what? C5, C54, right? Because that why is that? Because this is in total we have 6 here, right? So we have 6 minus 1. Since we have fixed this putting H here, it means that we still have 4 V's within the remaining 5 numbers. That's why the total combinations of here is like C5, 4, which is exactly the same numbers, right? With who is starting with H. Okay. Yeah, and after we have putting a V here, we'll just subtract that number of combinations starting with H from the K, and we'll keep doing it until we have finished uh, constructing all those instructions. And that's our basic solution here. So I'll try to explain a little bit more here. So basically we have destinations, right? Destinations. So the M is the is V, right? And H, I'll put like this is like the V count, okay, right? So and this is the the H count, okay? So and then we have a answer equals to empty, okay? And I'm going to have like this for I in range at the beginning, since we have in total V count plus the H count, right? In total. And then here I'm going to have like start, right? Start with H. So all the numbers start with H, how many do we have? So in Python, we have this combination built-in functions that can help us do that, you know. So we have like this minus I and minus 1 because that's the current. Okay, so first thing, this is the current the remaining numbers of the current numbers. But since we are trying to get the numbers, all the combinations starting with H, so which means that after fixing H as a current I, and then the remaining length is minus 1. Okay, and then we have like the downs. Okay, so I'm also going to define another here. So like remaining V. Okay, so at the beginning we have a V count, right? We have a remaining V here, and this is the starting with H, the combinations that who is starting with H. And now we simply just need to do a check here. If the K, so K means that we still need to make this case the case numbers who is currently bigger than the current number, right? Because we're looking for this case smallest number, and we still have this case remaining here. Basically, if the k is smaller than the target, than the start with h here, it means, so what does it mean? It means that we have this many, we have this many this numbers, this combination who is starting with h, and even this one is greater than the remaining smallest number we're looking for. So what does this tell us? It tells us, you know, let's say, for example, we have a x, right? And here, let's say we have we're deciding what which number which instruction where we need to put it here, right? Let's say at this moment k is equal to 4. Okay, and we have five numbers left, right? And the we only and there are only four numbers we need to look for, right? So which means that it has to be h here, because here it can be like H, H, or V, V, H, something like this. But what if we're putting a V here, even though we're putting H here, right? So we're way over than this like K fourth smallest number at this location. So that's why we have to put H so that we can get, after filling in all those kind of instructions, we can get the fourth smallest number, right? Okay, so that's why here, then we have to do append h here. Else what? Else is pretty so the other way, right? Else we do a v. So this is the other way around. Basically, if the current k is too big, then the cases who is starting with h, then we have to put v here because we have to skip this many numbers. Okay, and then after doing that, right, since we have skipped all the numbers that start with h, now we will basically subtract those numbers from the k, and now the updated k is the remaining numbers we need to be looking for, right? And since we're putting a v here, I'm going to also decrease this remaining v by 1. Remain. Okay, and here later on I just need to return the answer here. Okay, yeah, so let's run the code here. Okay, cool, submit. All right, cool. So I mean, as you guys can see here, right? So what if the k is very big? Okay, So if k is so big, and ideally we should have like all we all know it's going to be v v v and h h h, right? Because that's the biggest number, right? So how would this thing works here, right? So that means k will always be greater than the start with h here. So it means that we'll always go to the answer here, right? And we try to decrease the case by this, and then, but again, the k is still bigger than this, so we have to put a v here. And yeah, until what? Until this like remaining v equals to 0, right? So let's say the k is super big, and there will be a point, right? We have used all the v's here, and now we're at h here, right? So if we're at h here, the combinations here, right? So the combination of here will be okay, let's see. Um, I think that so it won't happen because I just realized that there's a constraint here. So k will not be greater than the total combinations of the row and the columns here. So yeah, so basically it won't be that case. It won't happen. So it will always within the range here, and this will always work. So how about time and space complexity, right? So I mean we have a let's say we have m and n here, right? So of course this is a O of m plus n, right? And how about this combination? Okay, I mean this combination, the so the way we're calculating the combinations will be pre-calculating uh, a pre-products from this m from m plus n, and here it's gonna be a O of 1 because if we are trying to calculate this one, we'll be having like a pre-products here from pre-products. Okay, pre-products with a range of the from this is from 0 to m plus n, and here we'll just use the values we have previously calculated. So here it should be like a O1 here. So the total time complexity, it should be a O of m plus n. Yeah. Okay, so I think that's it for this problem. Um, I think it's a pretty tricky problem, at least for me. Yes, because I'm not that good at this kind of math problem. So this is something we all need to keep learning, to keep learning. So yeah, and again, so the key point for this problem is that we just need to know this way of calculating all the basically all the combinations or all the remaining instructions who is starting with h, and then with this number, given these numbers, and we check if we can afford skipping, right? All those kind of h's. If we can, we go with v. If we can't, then we go with h. Right. Cool. That's it. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.